we can access here. So typing a Word document, programming a small sample program, or creating any document, making any suggestion, making any video call. So all this comes under. So all this comes under operating system. Then coming to the desktop. So desktop is the main thing where the main folders are to be kept. Once the software is installed, then it is very easy for the user to communicate with the computer. Then coming to the, see, normally a computer it should work very smooth in such a way that once the hardware and software components must collaborate with each other. So it is the main responsibility of the user to sit and to access to the computer and to give a clear instruction for the computer, because computer cannot understand. So whatever the user gives the instruction, the computer will follow it, and it takes our instructions by considering as input, and we are going to get the output. So some of the examples what we can see here is that Windows, Linux, Mac OS, and Android. Coming to the computer, how the computer is worked, let us see the step-by-step process. First, we need to power on. So we need to have power switch, then we have to switch on. Then the electricity flows into the motherboard. Then coming to the second step comes under BIOS, Basic Input and Operating System, and the firmware infrastructure. These both start say a basic foundation for the operating system, because once it get switch on, then only it start loading into the software. Then coming to the OS starts. Now we have to start by using either RAM, ROM. So RAM stands for random access memory and ROM means read access memory. Then user interface appears. So user interface comes under desktop, because we, the user, we need to access through desktop only. Whatever the icons and what are the applications present over there, we have to open that and we have to access into that. Then login screen. Applications run. So once all the software has been installed, we have to start running the application. Then if it is working, depending upon the software, a 32-bit or 64-bit, we have to run upon the software. So mainly the CPU plays a major role in operating system. CPU stands for central processing unit. So this central processing unit performs all the arithmetic operations, memory operations, all the input output operations will be accessed here. Then coming to the, what does operating system do? Operating system performs the following tasks. Let us see one by one. The process management. Process is nothing but a work that is in execution is called as a process. So what are the works we are going to do? Are we creating a Gmail? Are we accessing a program? Are we installing any software? So all this comes under a process. Are we playing a game, etc. Coming to the memory management. So what type of, how much memory it is storing? Either 500 GB or 60 GB, how much ever it may be. File management. However, we are saving a file. We are reading a file, we are writing a file. Basically, a file can perform two operations. One is read and as well as write. Read is nothing but just checking the document, and write is nothing but either deleting the document, adding the content, or removing the content. This comes under file management. Then coming to the device management. Device can be input devices, keyboard, mouse. Output devices can be printer, monitor, scanner, all this comes under output devices, because without these devices, the user cannot give the input and cannot take the output. User interface. So mainly we are having two types of interface. One is command user interface and second one is graphical user interface. So command user interface is the one where we are going to use the command by using command prompt. CMD is a shortcut. Then graphical user interface, by making use of these icons and all, we are going to create. So a small application is called as a graphical user interface. Then coming to the security. So how much security it is providing for a user by using passwords or giving access permissions? Because every user will not be getting a permission. Only the authorized user, they are going to gain the permission for this. Coming to the real life, let me take one small example over here. Let me take the example of a hotel manager. So here the operating system is considered as a hotel manager, and then the CPU is considered as a chef. Then RAM, random access memory, is considered a kitchen workspace where they're going to work. And then hard disk, it is a place where all the food beverages will be stored. Then applications, where nothing but the guests coming to the restaurant and ordering the food. Then the input devices, keyboard, mouse comes under the waiting person who is taking the orders. And output screen will be printer or scanner. All this comes under output devices. Then it comes under serving the dishes. So finally, the operating system, coming to the real time example of this, we can conclude that operating systems run smoothly for the every user once the applications has been installed properly. Then Coming to the functions. So let us see the functions, what it's going to perform. Coming to first one, device management. So it keeps track of all the devices, how it is going to work, everything. So all this it is a responsibility of the CPU to take control over it. If any if any problem occur, it's the main task of the control unit to make over it and to see to it that no error occur, and in such a way that the system crash and system failure should not be any problem. Then coming to the file management. So nothing but allocating certain amount of resources, how where we are going to store the data. Because each and every place we cannot store all the data. So there must be a separate allocation for program files, separate allocation for the individual files, separate allocation for all the audio video files. All this comes under the file allocation. Coming to the job accounting. So what suppose if you are downloading a movie, how much time it is how much how much time it is going to take? How much time it is going to take for a job allocation? How much how much time it is going to come? How much time it is going to take? That comes under job accounting. So either it is taking a limited amount of time or it is taking a excess amount of time. If it is taking a limited amount of time, then that software or hardware is considered the efficient one, or else we have to re-update the new one. Then coming to the next function, error detecting. So whenever any error occur, the operating system will see to it that as early as possible, it need to come out of that so that the next task should not be in waiting state. Next, memory management. So how fast memory? We will be having two memories, primary memory and secondary memory. Primary memory, where we are going to store all the program files. Secondary storage comes under the outside devices, pen drives, CDs, DVDs. Processor management. Processor is the main thing in a operating system. Without processor, operating system cannot run. Any processor, Intel, all this processor will give a strong, strong foundation for the operating system working. Coming to the control and system performance. Suppose if any error occur, how much time it is taking for the delay? Because the next upcoming task should not wait. So it must be the next wait. The task is nothing but any job. I mean, running a program or playing a game or writing a document. All this comes under a task. So how fast it is doing? So all this comes under controlling system performance. Security. So not all the users must gain access. Only the person who is having a proper authentication, they have to log in and they have to check the details. Coming to the convenience. So convenience, a OS should be very, very convenient for using so that all the user must be very efficient in accessing that. Ma'am, is it okay? Ma'am, is it okay?
Yes, ma'am. Yes, sure.
Okay, okay. Okay, fine. Thank you. So the ability to evolve. So the OS should be constructed in such a way that for developing any work or for doing any testing of the errors, it must be in effective way without any interrupt. Coming to the throughput. Throughput is nothing but the number of tasks it takes per unit time. Suppose if you're executing some 10 amount of task within the given amount of time, the number of 10 tasks must be completed without any delay. If any delay occurs, the current task must be kept hold and the next coming task must come inside and it has to perform. Because waiting itself takes the operating system leads to more hang on and also system crash, system delay. All these issues comes because of the software. So it's better if you update the software thoroughly and if the antivirus is kept thoroughly, a operating system will support very effective way in for the user application. Then coming to the components. So what type of components must be used here? So let us see the diagram over here. So let us see the diagram over here. See the application program. So here application programs, system programs, user interface, process management, memory management, input output control, file management, CPU, main memory, input output devices, storage devices, all this comes under here. Let us see one by one. The process management. So what task is performed? It checks for the execution of the program, and it checks for the program data and the stack and stack pointer. So stack is a data structure where it performs a insertion and deletion of the elements, and which follows the order last in first out. Then pointer is the one which stores the address of the variable. Coming to the program counter, it stores the address of the next upcoming variable. And CPU register, it's a place where the data will be stored of the user. Suppose if a user is downloading some 100 files, those 100 files records will be stored in the register. Register is nothing but a storage device in the computer. Details of open files. So what files a user open and what operation he has done, either deleting the document or editing the document, all this comes under open files. This is a diagram for process management. It's nothing but a life cycle of a thread. So it starts with the new state, then coming to the ready state by performing the admit. If once a user click admit, they goes to ready state. Then coming to the running state. Running state comes under if the process is running, it comes for the running state, or else if any error occur during the ready state, they have to come for the block state. And also if suppose if the time is out, then also they need to come for ready state and the task will be blocked. So the ready state will have if any error occur, the ready state will immediately move the thing to the block state. Then once all tasks will be completed, then the running state will move to the exit state. So there we have to release the task. Task releasing is nothing but completion of the work operation. File management. So file is nothing but a collection of records. It can be a Word document, any PowerPoint presentation, PDFs. So all this comes under a file. So it is treated as an abstraction because only the information needed for the user will be provided here. Otherwise, they will not provide. So it performs mainly three operations: file creation, file deletion, and read and write operations. Then coming to the structure directory. See, root is not, it forms a basic tree where the root directory means where the file has stored at the main part. Then comes in the subdirectory where the file has been stored in the next initial stage, and then the newly inserted file will become at the subdirectory. So everywhere the file is stored, but the root directory will be having the details about all the files. Coming to the command interpreter. So command is nothing but giving some instruction to the computer in terms of a Linux or Unix software and by using command prompt. So normally it executes the commands in two different ways. One is it itself contains a code to be executed. For example, check upon the date, config, ipconfig. So these are some of the commands. Then coming to the system file. So suppose if you want to take some 100 MB of data, so we need to have 100 MB of the storage into that. If you're having less amount of storage, the command will not accept and the data will not be stored. So a user must be in a position to have enough storage space, then only we can enter the data into that. Coming to system calls, these are the basic thing. It's a basic important thing in operating system because system call is nothing but making call for a particular component to do an operation. So this comes under the basic thing in operating system. So let us see some of the operations performed by the system call: process management, memory management, file operations, input and output operations. Here in system call you'll be having a library functions, some predefined library functions. By using that functions, once a user give that particular command, the operating system will receive the command and it is going to give the output. If the command is not right, then it is going to display the error. Then signals. It is nothing but notification of particular event. Suppose if the user asks for a opening of a Word document, then how Word document will be installed? First we need to open a Word document, type in that, save in that, then printing the document. So if the user types any wrong command, then it signals it is a wrong word. We need to check for the error. So it's only the signal is the one it is going to notify the user whether the command given is right or wrong. Then once delivered, the signal must be handled. So suppose how if any error occur, then what type of command we need to rectify the command, and we need to be, there will be a default handler to handle the signal. Suppose if any serious error occur, the user must be very caution, see to it that no data loss should occur. Coming to network management, then it is a basic thing. Network is a basic thing in today's world because without internet, we cannot do anything. So network should be very, very efficient, so that the user must be in a position to access all the resources. Whatever it may be, they're playing any game or downloading a document, or uploading a document, or creating a website. All this comes under the network management. Mainly the configuration important plays a major role here because without the configuration of the operating system, network management is unimaginable. Security management, it's a very, very important thing because only the authorized person, whoever takes a login. Suppose, let me take one small example here. If you want to create one Gmail account, what are the things you need to provide? So first you need to give one proper, you need to give your first name, and you need to give your proper details and date of birth, all those. So once your authentication is correct, then only the authorized person will give you access for the Gmail account. Suppose if you are not giving any details prescribed by the admin, you are unable to create a Gmail account. So this comes under security issues because each and every user data is very confidential, and say it must be maintained in very much secure way. So it should be a one-way communication, and also once you enter the details correctly, then only the admin or authorized person you're going to gain the access of your account. And also, if you're opening the same account in one more device or any other device, so what type of message you're going to get? You are going to get an alert message. So this alert message will be provided by the security management because once the data once the data is kept outside, then there's a chances of hacking the data. So this is a primary concern in the security management. Coming to the input output device management. So input output devices, without input output devices, we cannot do anything, right? So a keyboard, mouse plays a major role, and output is nothing but the printer or any other thing. So whatever we are going to connecting. So without these devices, a user cannot give a certain amount of input to the computer and also taking the output. So desktop is said to be one type of output device because we are going to see in the screen, right? So all this comes under the device management. So we must be in a position to access the keyboard and mouse and also checking for all the devices that are ensured properly by using the USB drives. Then secondary storage management. So secondary storage comes from the outside. It can be a CD drive or DVD or any ROM devices, flash memory devices, pen drives. So all this comes under secondary storage. So suppose primary storage is available, but if any error occur, so we need to have one secondary storage device so that we can retrieve data very easily. Once data loss is performed, it is very difficult to regain once again because because in hard disk we cannot guess the data will be available or not. So that we need to frequently update the software and we need to frequently update the antivirus. So all these things must be kept very efficiently so that the secondary storage will be performing well in the hard disk. About the main memory management. So main memory, so it comes under the random access memory. So which is a main computer storage here. So it is very expensive and in terms of storage as compared to the secondary storage because secondary storage, there is no guarantee of the secondary storage devices, but the main memory will be having a permanent storage. So that's the reason main memory will be having a very expensive details compared to the secondary storage. So the user can permanently store the data here. So there is no chance of data loss in the main memory. So you will be having two memories here. One is main memory and secondary memory. Main memory is a permanent and secondary memory is a temporary. What are the main goals? Let's come to the goals of operating system. What are the main goals of operating system? See, every user operating system means they need to interact with the computer and they need to access all the resources without any delay or without any error. So if any delay occur, then we need to switch on to the next operating system. And if any error occur, we may face the loss of data and also system crash, everything will occur. So the first and foremost responsibility of the operating system is to control all the computer resources. Resources comes under all the hardware components, motherboard, bridge, north bridge, RAM, ROM, and the software components comes under all the applications what you're going to install into the Windows operating system and whatever the antivirus and all these operations should be, resources must be accessed very, very efficiently. Then it must provide a valuable services to the user programs. So whenever the user gives any command, so the operating system must receive the command and it must give its output to the computer, to the user. Then only the user will be satisfied. Then it must coordinate the execution of user programs. Suppose, for example, a user is executing some 10 amount of programs. The computer must be in a position to handle all those 10 programs and it must give output for the user. Then it must provide an interface. So virtual machine. So as a machine, we interact with the computer by using the output input devices. So it must provide efficient resources for the user programs also. It must hide the complexity of software. Nothing but if any error occur in the software, so how it is going to handle the user, immediately switch off the computer or immediately crashing the data. So that is not the thing. So the computer must be in a position to either give instruction for the to the user. Okay, the device is inactive, you must provide, you must do some necessary things to keep your operating system active. So the user will be alert, then he can do the necessary things to keep the operating system in a good effective way. Then it supports multiple execution modes, and it also monitors each and every execution in order to prevent the error at each and every step. Suppose if you are executing a program, a C program or Java program, so the each and every line the error will be checked, because instead of checking at the last moment, you can check at the initial point of view. Come to the evolution. So when and where the evolution of operating system has been started. First, it has started in around in the year 1940. It's the early beginning stage. So computer operated without operating system. It is just manually loaded and run one upon a time. So it has been introduced around 1956 year. Then coming to 1960s, where the multi-programming and time sharing has been taking place. Because multi-programming means a user cannot perform only one single task at a time. They have to do multiple programs. And also, it must be in a position for time sharing also. Nothing but how much amount of time a task need to be completed. Some 1 hour or 2 hour. If more than that, the user can shift on to one more task. Because giving more time for a one single task can make delay in other task also. Then it allows multiple user to interact. So that's the thing. Only one user cannot do all the task. Once the task is completed or before the task completion, they must gather all the resources from the other user also. So there must be a two-way communication so that the work will be very easy. And because of this operating system only, the user is able to share each and every data. Then 1970s. So here Unix operating system came into existence. So mainly different personal computers around CPU STAM and PC personal computer, DOS command computer has been introduced here in the year 1971. Then coming to 1980s, here the graphical user interface, which plays a major role in today's world by using, because we are using apps in today's life, right? Such as Android and iPhone and Apple. So all these operating system will be taken care of this GUI only. And also protocols such as TCP, IP, transmission control protocol, internet protocol. So all this comes under 1980s. Then come to 1990, somewhat advancement of the graphical user interface. The Windows came into existence, Windows XP, Windows 7, and Windows 7, 8, 10, 11, 12. So these are the versions going on in today's day-to-day life. Normally, the once Windows came into existence, it has a widespread range in and around the world. Every user started using the Windows operating system because a user feels very comfortable in using the Windows operating system. Even for that Windows also, some sort of operations has been taken place in the year 2000. So mobile operating system. So today mobile has become a part of a necessary device in our day-to-day life. So Android version came into existence here. Then coming to the cloud base. So without cloud, nothing is going to happen here because every user data is going to get stored in the cloud. So not even one single user. If you have more than some billions of users data will be stored in the cloud only. Because even the system crash also, the cloud will be giving you the backup for the information. Coming to the AI alteration. So this is the present ongoing trend. Artificial intelligence is becoming a viral and trend in today's world. So it came into picture where we have got many different AI, robotics, Siri, Alexa. So all these types of Google assistants we have got here. Chatbot, Meta AI. So we are experiencing all these AI, artificial intelligence techniques in our day-to-day life, where we are getting more and more information within a less amount of time. We are getting very close to the world once this artificial intelligence came into our life. Coming to the architecture. So there are different types of architecture here. One is simple architecture, monolithic architecture, microkernel architecture, hybrid kernel architecture. Let us see about a simple architecture. Here we can see the diagram. See, application program is where the software has been installed in the application program, and the user need to interact at the stage of the operating application program only. Then coming to the resident system programs, it is nothing but the interior point of view, the user cannot see. So it is a task of the computer to take the instruction from the computer from the user, execute it and return back to the application program. Then coming to the MS-DOS device drivers. So these device drivers helps in receiving the input, processing the input, and also sending back the output for the user. Then ROM BIOS. So read-only memory and basic input-output devices must be in a position to receive all the commands given by the user and send back to the operating system. Then monolithic structure. You can see the diagram here. See, it consists of basically application programs, and where application programs is get of two different types. One is process management, file management, and also the drivers and the hardware. Right. So process management. So how far a program can execute? Process is nothing but some collection of tasks. So how many tasks a user can execute? Some 100 amount of tasks, and how far it can execute. And also the file management, where the data is going to store, either a primary or secondary storage. That depends upon the user, but all the data will be stored in the primary storage. Then coming to the drivers. Coming to the drivers. So here the drivers is going to have here the drivers. Here you need to consider important drivers such as RAM, ROM, and all those important components here. Just a minute, ma'am. Just a minute. Okay, sorry for the interruption, ma'am. Right. I think my voice is clear, ma'am.
Yes.
Okay, thank you. So let me continue my presentation. So here in a monolithic structure consists of two important factors. One is process management and the next one is file management. So how far the data can be stored in a file comes under file management. Then coming to the process. So how many amount of task it perform? So either 10 amount of task, 100 amount of task, or 200 amount of task comes under process management. Then coming to the drivers. So how the drivers will be installed here? So either drivers is something but the ROM, how much GB it is going to take, 4 GB, 8 GB, all this device comes under here. So without the drivers, we cannot do any task in the operating system. So all this collection of components comes under monolithic structure. Microkernel, it's a very small component. See, normally operating system consists of two major components. One is kernel and the next one is shell. So kernel is the one which is going to access by using the computer, and the shell is the one which is going to provide some sort of services to the operating system. Then it is independent to one another, and also the device drivers, memory management. So all this work collaboratively to perform a certain operation by using the hardware devices also. So how fast it can access it. So how fast it is going to provide the output comes under microkernel. Coming to the hybrid kernel structure. So hybrid kernel, it's a layered form structure where it start the bottom layer comes under the hardware part. Let us see the diagram over here. So in the bottom layer, we are going to see about the hardware, and upcoming the layer two, where they are going to have system programs. And coming to so on, the layer n will be having user interface. The user is the one we are going to interact at the topmost level, the user interface, because we cannot go deep inside in the computing system. It acts as an abstraction processor. So that's the reason why every user will be interacting with the computer by at the top lowest level called as user interface. As I already told you, the interface consists of two different types. One is command user interface and the next one is graphical user interface. Then types of operating system. So we are having batch operating system, multi-programming operating system, multi-processing operating system, multi-user operating system, distributed operating system, network operating system, real-time and mobile operating system. Let us see one by one. Batch operating system. So let us see the diagram over here. See, batch is nothing but a group of tasks, a group of job. Job is nothing but performing a particular task. So it can be printing a document, it can be programming, typing a program, it can be playing a game. All this comes under a job. So how many jobs they are doing? If a user is doing 10 amount of jobs, it comes under a batch. Group of job is called as a batch. So here, every operating system must be designed so that the user can access in a more amount of job at a time in some sort of groups. Multi-programming. So how far multi-programming will be taking place? So normally, if you're downloading a document or if you are playing a game, like executing a program, all this comes under multi-programming. Whatever the programs it takes place, it must be effectively in a position to take the operating system must take care of all the multi-programming tasks. See to it that within a given amount of time, the task must be completed. Then multiprocessing. So it must be in a position that one CPU is used for the execution of the process. Because by using thin client software, we can connect all the components. See this. You can see the diagram over here, right? So memory consists of two parts here: CPU, register, and cache. CPU stands for central processing unit, and register is the place where we are going to store the data. And cache is it's some sort of storage for a temporary buffer like thing. So all this thing it is going to get processed in a multiprocessing. So whenever the task comes from the user level point of view, the CPU is going to process and then it is going to get the data stored in the register, and any unwanted data will be get removed by using the cache memory. About multi-user. So how many users you are going to have? Some 100 amount of users or 1,000 amount of users. Whatever user it may be, the operating system will allow to access all the devices and all the resources for every user. So that's the main important task for the operating system for making effective use of the resources. Then distributed operating system. Here you can see the diagram. So how distributed means nothing but the resources must be divided for all other users here. One is for between CPU, memory, and disk. Disk is nothing but hard disk, and also between CPU, memory, disk. So how they're allocating the task? Suppose if we are having some 10 amount of files, the data must be split into required amount of memory that is present in the CPU. So suppose if you're having some 50 amount of data, 50 amount of files, it must be divided into equal parts as of the memory storage. And the remote access should be enabled because we cannot store all the data in one single computer. It must be shared to all other users. That comes under distributed. Because in centralized system, once the error occur, all the system will get collapse immediately. But in distributed, if one error occur, only that particular system will get will be getting error. The remaining systems will be worked effectively. That's a thing. Why? Because every user is following today distributed operating system only compared to centralized. Then coming to network. So network is nothing but connecting different clients by using a server. Here you can see the diagram. Here client 1, client 2, client 3, and file server will be present at the center point of view. So the server it is going to connect different clients. So because the client server is nothing but a handshake process. Because nothing but the client is asking some request by using any Google. So server it is going to take the request from the client and it is going to give the output. So if the user data, whatever the query typed by the user, if it is correct, then server will give the correct output. If the server is unable to understand the question, then it is going to ask for the reback of the question. So here it takes place the client and server communication, which we call as the handshake process. Nothing but we can take, and it is also called as a tightly coupled system. So because the bond should be between client and server, then only whatever the client query ask, the server must be in a position to get back the data from the database. So once the server collects data from the database, it can transfer that it can transfer the data to the client. Coming to the real-time operating system. So real-time operating system here we can see the diagram. So kernel and also the batch chat processor must be having the interaction with the application, because the user will be at the topmost point of view. So how much it is going to access and how much they are going to consider. So how many users they are going to access this operation. All this comes under application point of view. And also the best example for this real-time is nothing but air traffic control system and also the robot. So they are configured in very effective way, so that the user also can make use of it. Custom hardware. So here the hardware can be constructed by our own individual components. Suppose if you're considering some CPU or some hard disk storage, some 500 GB, so like that. So how much amount you can put, or how much storage you can consider. It is the individual will and wish of the customer or the user to make access of it. Mobile operating system. So how mobile? So today mobile has become a thing, a common thing in each and every life. So here we are having Android mobile, iPhone. So many devices we are having. So how it is going to connect? So example, suppose if you're watching any game, or if you're playing any game, if you're downloading any document, if you're editing a document, all this comes under operating system. We have got many apps. So all app will be operated by the operating system, Android as well as iOS operating system. Coming to the booting and dual booting. So without this booting and dual booting, operating system is unimaginable. So booting is nothing but, suppose if you switch on the if you switch on the computer or laptop, the time it takes for the opening of the software or opening of all the applications, that calls as a booting. Loading of the software comes under the booting. So it performs. There are two types of booting here. One is cold or hot booting. So here, once the computer is switched on, so it is called as turning a power on the computer. It comes under the cold or hot booting. Then the soft or warm booting. So it reboots the computer without shutting down entirely. Suppose going to a sleep state or going to resume state. So all this comes under soft or warm booting. So it is normally performed for a particular by using any shortcuts only, such as resume or sleep mode. So all this comes under soft or warm booting. Then system call. So system call plays a very major role, because we have already discussed in the previous PPTs also. So system call, once the user wants to perform any operation, or they want to download any file, they need to put some command to the computer. Then only by using the command only, the computer is going to take that instruction and is going to give the output. So basically, kernel and shell are the two important major components in this system call. So kernel is the one, it's a basic core of the operating system, which manages both hardware and resources. And the shell is nothing but it acts as the interface between user and kernel. Because user cannot go inside the computer and they cannot do all the tasks. So our task is nothing but switch on the operating system, switch on the computer, giving some query for the computer by using certain commands. And it is the responsibility of the operating system to take that command, to receive the command and make processing of it and giving the output for the user. So all this comes under system call. Let us see some types of system calls over here. The file system. So file is nothing but a collection of records. So either you want to the operation performed here, or write operation, opening a file, closing a file, and editing the file. All this comes under a file system operation. Then we can see here seek operation is nothing but searching of the file. So how it is going to take place. Then coming to process control. So process is nothing but doing certain tasks. If you're executing a particular program, so how we are going to give the output, and how we are going to gain access for the resources present in the operating system. Here comes under waiting state, exit state, and also the kill state. Suppose the kill state is nothing but if you are doing any particular job, playing a game or typing any document, if the particular document is not opening or it takes some long time for accessing, then we must close a particular task and move on to the next state. This comes under the kill operation. EXEC comes under execution. So how far we can execute the task? Suppose if no error occurs, then we can execute the program immediately. Then come memory management. Memory management is nothing but suppose I already told you because if memory is insufficient for a data storage, we need to divide the data into equal parts. Suppose if you're having some 1 GB of data, we need to split into equal parts so that the data will not be allocated for single place. It leads to more amount of storage and the upcoming data we cannot store into that. So this comes under the memory management. And for the different operations where we can provide the log also so that our data will be very secure and safe here. Inter-process communication. So it comes under it's a major thing because open system will be having a thread process here. Thread is nothing but a lightweight processor where it is going to have data processed, data stored, and also each and every job performed will be having a unique amount of records. Because if the user feels difficult in performing a particular task, the thread and the process will be making note of a throughput time. So by using the throughput time only, they are going to analyze whether the particular task taken is considered as it is completed within the given amount of time or it is taking more amount of time. If it is taking the more amount of time, then the task is going to be we need to abort or either kill the job or we resume the job, and then the upcoming job must be in a position to come to be ready and we need to do the task so that the user must not delay. The user satisfaction is very important in operating system. If the user the user is inconvenient in accessing the operating system, then immediately we will shift for the one more operating system. That's the reason the effective use of resources must be in a position for accessing the resources. Then coming to the device management. So device management. So what are the devices you're going to connect? Input devices, output devices, how we are going to access into that? What thing you're going to perform? By using connecting the USB drives or by installing the applications or whatever it may be, the computer must be in a position to support to it. Then coming to the applications of operating system in real world. So how computers will be operated? So today, day-to-day life, everyone is having the laptop, personal computers. So we need to make use of Windows, Mac OS, Linux operating system. So depending upon the user interest, every operating system will be accessed. Then mobile devices. So smartphones, mobile apps, tabs. So all this comes under a mobile operating system. Embedded systems. It plays a major role in space stations and also in medical devices, aerospace, spacecraft. So all these things, embedded systems will be applicable very easily. Industrial automation. So manufacturing any product comes. Suppose let us take one laptop manufacturing only. So it takes enough amount of time to prepare a laptop. So the company must be in a position to install all the software, all the components needed for the needed for the laptop, and it must be automated. Networking. So it needs to man by considering we are having networks for basically local area network, metro area network, and wide area network. So depending upon the area specification, these three types of networks will be used. One is LAN, local area network, and WAN, wide area network, and the next one is MAN, metropolitan area network, enabling the data communication. See, basically, operating system, whatever it may be, the user must interact with not only with the computer, but also the user must interact with all different users. So one such thing what we are going to do here is data sharing. By using a laptop, by using mails, we can share the data. By using mobile, we can share the data. Data sharing is very important because communication plays a crucial role in knowing any important fact in and around the world. Without communication, we cannot do anything. Then cloud computing. So today, cloud is said to be the basic era and in and around the world. Without cloud, nothing is going to happen because user data wherever we store, it is not final. Sometimes or sometimes or other, if the error occur, the data will be crashed permanently. So it's a very safer side to store the data into the cloud, so that whenever we want, we can go and back up the data, and it provides a good amount of storage. One such example for the computing is Google Drive, where we can store our data because by using Gmail we are going to log in into our mobile or our laptop. So immediately the data will be stored in the Google Drive. Whenever we want, we can go and retrieve and back up the data. Then coming to advantages and disadvantages. So what advantages is operating system provide? So it provides a major interface between user and a computer, and then it's a user friendly because a user cannot put more efforts in one particular operating system. So they must be in a position to access very easily, and also how efficient once a user gives query, how efficient the operating system will respond comes under this basic advantage. Then disadvantage. So it is having a memory access, broadened memory access time leads to page table query because it is not related to one single user. They'll be having some billions of users. So the operating system must be in a position to maintain all those records in a register, because if particular user is having a one or 10 suppose the user is having one or more mail id, then they must be in a position to access the mail id and store the password, and all those details it must be kept very safely. So let me conclude. So the operating system. So operating system is a major fundamental thing to functioning of any computer, and it includes the process, memory, file management, essential for the efficient and secure computer operation. Whatever the task performed by the user must be very safe and secure. That's the major important thing of the operating system. So operating system will provide such flexibility for every user to go give some commands, take the input, and also take the output by providing a proper input. Then it also offered good networking capabilities also, because without network nothing cannot be done. Data must be shared or received from other people also. These are the references. Any questions? Any questions, please?
We have some questions from participant already read in the Zoom chat.
Okay. Yes. Okay. I think we have got a question here. How does operating system manage the competing demands of multiple programs, crashing and freezing? Okay. The question here is that if the user, only for single user, it is not possible to perform all the tasks and to take all the data from the computer. So they must be in a position to keep the operating system frequently updating, and also keeping the antivirus safe, so that the operating system will not be in a position to crash. So next question: to what extent do modern operating system balance user friendliness? See, first of all, user must be efficient to interact with the computer. So that first they need to know how to how to operate the operating system, and whatever command should be given, how the computer will understand. Because we can know all the languages, but computer will know whatever we give input, it is going to take that, and is going to provide the output. So we need to interact with the computer in its own language only. Between the trade-offs and responsiveness of the fairness, right? So because if any task is scheduled, So how much amount of time it is going to execute? We need to analyze first. Suppose if you are typing a document over there, if it is taking some half an hour, if it is taking some 30 minutes of time, so how much time you are going to take, and how much operating system is going to respond? If it is giving good response, that is fine. Or else we need to shift for one more job. We should not wait a particular time, because if a operating system is making delay, then that operating system is not good enough. So we need to shift on to new operating system, so that we need to keep antivirus update, and also frequently updating all the device drivers. By using all these things, by doing all this frequently, we can avoid utmost amount of system crash or any delay in the work.
Already? Already?
Okay,
Ans- Oh, yeah. Okay, I guess no one else asking again. Okay, thank you for your answer. Before I close this event, for all participants, please open your camera. I will take a picture on the count of three. Okay, one, two, three. Okay, another one. One, two, three. Thank you. Thank you for your keen cooperation.
thank you.
Finally, we come to the end of visiting lecture today. We would like to thank you for Miss Nivedha for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have more collaboration in the future. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice day. Thank you
Thank you.
and
Thank you very much.
goodbye.
Thank you. Thank you.